Hello, everyone. A very good morning to all of you. Myself, Dr. Muhammad Imdadul Haq. I'm an associate professor at the Department of Economics at Aligarh Muslim University. I welcome you all to this lecture of econometric methods. We are we have as such completed our simple linear regression and its related things. The basic of simple linear regression. We have completed how to derive the alpha hat and the beta hat, that is the parameter. Then we moved on to the Gauss-Markov theorem. We had seen the importance of the error term. We have seen the assumptions of the classical linear regression model. Now we will be moving to multiple linear regression. But before going to multiple linear regression, let us have some practical demonstration of how to solve these things using an Excel sheet. And then we will be moving to multiple linear regression. So today we will be conducting our class through an Excel sheet. Let us open an Excel sheet over here. Now, in the Excel sheet, there are hundreds and thousands of formulas and many numerical and mathematical things you can do over here. Our basic purpose is to go for explicit thing like regression. Now, in one of the tabs, like see, we have home, insert, draw, page layout, formula, and data. In the tab of data, if you are using your Excel sheet for doing analysis, it will be coming like this. I would do a bit of work over here and you will find a new item appearing over here on the right hand side by the name of data analysis. And how it's done, we will see. We will go to file, we will go to options. In options, you will go to add-ins. In add-ins, when we click on go, you will find these add-ins are available over there. They are already present in your office, MS Office, they are present in your Excel, but it's not activated. We simply have to click on OK. And now, as I said, over here data analysis will be present. Earlier, it was not there. A quick recap, go to file, go to options, go to add-ins, go here, click. Earlier it was like this, or in your system, if you have not used it before, it will be like this. You check mark on the first one and then you have this, click on OK. So now you have your data analysis over here. Next, let us we take an example. Say we take an example of accident. And we have certain numbers of accident as say 8, 9, 10, 11, 12, 13, 15, likewise 20, 30, 50. We have just taken a few data sets. Let us take one more. These are the number of accidents which we have. And if accident is your dependent variable, then you have your independent variable, that is say speed, because accident is normally caused by speed. We have speed as say 40, 50, 60, 70, 80, 90, 100, 110, 120 and 130. We have data for Excel. We are just taking hypothetical data, so this would be denoted as X. See, we all know what is a dependent variable and what is an independent variable. A simple thing could be like, see, what happens first, you can say, is the independent variable. First, there is a speed and then there is an accident. So, what happens first is, you can say, is the independent variable, and then what happens as a result of it, You can say is the x is the dependent variable. Now, so once we have this data inserted in our system, you go over to data analysis. A dialog box will open up. There are n number of things which you read in statistics: ANOVA, correlation, covariance, descriptive statistics, exponential, and then you have this regression, t-test. These are all available over here. Let us take, if you will appreciate the beauty of this, we simply just like, let us do the descriptive statistics. We click on OK. I need to select all this. The data is selected. What you need is you need a summary statistics, and say you get that you need the answer on a new sheet. So with a click of the button, it's non-numeric labels because the names in the first row. Now with the click of the button you get, let me increase the size. With the click of a button you get all the things like the number of the mean of accident, the mean of accident, mean of speed. The speed mean is this, the standard error is this, median you get, there is no mode value as no speeds are repeated, then the standard deviation, kurtosis, skewness, range, minimum value, maximum value, sum count. With the click of a button you get all the things which are required over here. But our main concern is at the moment regression. Now, when we go, we select regression over here, then this dialog box comes up. It asks us to give the input range y. I have clearly written this is my input range y, and that is the input range y, that is a dependent variable. Then it is asking to input the range x. X is my independent variable. I select over the independent variable, and then there are labels in the first row. There are names. Labels means name, accident and speed. So I simply select that the first, I ask the computer to identify that the first row consists of names, and then it output range. Suppose I want the result to be here itself. Then I click on OK. This is your output sheet. The things which we have, although the things which we have studied till now, that alpha hat, beta hat, r square, standard error, t standard error of b, and the t-test, all things are available over here. This intercept, it's clearly written intercept. We are having a value of minus 35, although theoretically it's not possible. But see, we have taken hypothetical data. It's not that the process, it's not that the computer is giving you wrong results. But since we are just using an hypothetical data, it is giving us a result like this. So this is your value of alpha, which we have been discussing in our previous classes. This speed, this is the value of your beta or beta hat. So if I want to write this regression, if I want to write the value of the regression equation from this, so y hat is equal to minus 35.35 plus 0.74x, or in the case of here, accident is equal to, we can write accident we write it y is equal to minus 35.35 plus 0.74x. This is how we write this estimated regression equation from here. The next thing is this r. This is nothing but the Karl-Pearson correlation coefficient. This r is nothing but the Karl-Pearson correlation coefficient. Then we need r square. R square is, we have seen, R square is what percentage variation in the dependent variable is explained by its relationship with the independent variable. We need not consider adjusted r square. We will see that in the case of multiple linear regression. We stop it over here. Then next thing is we our calculated the standard error. So this is the value of our standard error, SE. Now we have calculated T stat over there. So here we have your T stat. In softwares, the one more thing is we need not do all those things like we draw the um, we draw the curve and then we say that this is the table value. You take it from in the back side of your statistics book or econometry books. You have the T table. You look it from there. Simply, you have that p value over here. This p value is used to determine the significance. And the basic rule is, because normally in business and economics we use 5% level of significance. In 5% level of significance means we allow for 5% of our error as such, we can say it in simple terms. So 5% is 5 divided by 100, that is equal to 0.05. So you have the p value of means this is the borderline. If your p value is more than 0.05, your null hypothesis is accepted. If your p value is less than 0.05, your alternate hypothesis is accepted. So what is the rule I'm saying? 0.05 is the probability. If my value is, if my this p value, like this is the thing which I'm concerned with. If this falls over here, then the null hypothesis is accepted, which automatically means alternate hypothesis is rejected. If this value is less than, this means that the null hypothesis is rejected. We automatically means that the alternate hypothesis is accepted. What is the null hypothesis? Null hypothesis is that the beta is equal to 0. Means here we are having only a sample of a speed. In real world there can be a speed of 30 also, and there can be a speed of 140, 150. We have not considered those things. In there will be other speed points like 41, 42. We have not considered. We have just taken a sample. And so the alternate hypothesis is beta is not equal to 0. It means then it is significant. So if this is accepted, our relationship is not significant. If all this h1 is accepted, our relationship is significant. So if it falls below, it is a case of significant. If the p value is more than this, then it is not significant. Here we see that the p value is 0.006159. So it is 0.0061, that is, it is less than 0.05. So we can say that there is a significant relationship between accident and speed, or in simple terms we can say that if there is a 1 unit increase in speed, there will be 0.74 units of increase in accident. We will take in future examples of this, and what I'm saying is the basic one at the moment. So we assume this what is said. Now this is what we have done till now. Also which now what does this r square means? That 62% of the accident, 62, we multiply this with 100, it gives you the percentage. So it says that 62% of the accident is because of speed. So remaining, that is 100 minus 62, 38%. 38% of the accident is not because of speed but because of other factors. Now, when you are referring to other factors, it can be anything. Like as an example, in the case, if we just hypothesize in this case, what are the things that can be leading to accidents? The quality of roads. If the road quality is bad, it will lead to accident. The quality of light, if there is no proper lighting on the road, the chances of more of an accident. Then you have this age of the tires. If the tires are worn out, if the tires are bad and you are driving fast on a highway, there is chance that there will be an accident. Again, you can have simple similar things like this. So what is being said is 62% of the accident is because of speed, and the remainder is unexplained over here, and that is captured by the error term. Then we have to see that this error term, uh, we are not going to see those things. That is the problems of heteroscedasticity and serial correlation at the moment. We are just trying to understand some of the concepts. Now let us change something. I incorporate some variables over here, like say tire age. We have seen that if the tires are bad, so the number of accidents will increase with an increase in the tire, with an increase. So we take that. I'm just taking hypothetical examples, okay? These are no real examples. So what is just shows that the tire age, this is 88 months old tire, this is 77 months old tire, this is 1 month old tire. Now, do you think what I have written, it will have a relationship like this? Although I'm taking hypothetical values. Understand that if the tire age is more, the accident is, this is the theoretical assumption. We are just saying a theoretical concept. If the tire age is older, the chance of accident is more. But what we have done, we have taken it a wrong way. So if we are having a variable like this, it will give you some else some result will not be according to the theory. So it is the work of, it is not that there will be a causal relationship just like that. You have to prove that relationship with the help of theory. So it should be rather like this: 2, 2, 9, 11, 22, 44. So instead of this, now this should be the case. Again, I am taking hypothetical. It's not that my answers. It may be that there's answers which we are getting. Like in earlier case, we got an intercept negative. That doesn't have, that don't make a sense. That doesn't make a sense over here. But nevertheless, this is just for your understanding of simple. Now we have moved to the realm of multiple linear regression. It's not now anymore. There is no one dependent and one independent variable. Rather, we have one dependent and two independent variables. So when we are increasing this number of independent variables, this is what you refer to as multiple linear regression. We are assuming a linear relationship. That's why we say a linear relationship. Now, we repeat the process. We go to data, we go to analysis, the same process. This dialog box comes up, then we go on and up in this as regression. Input, it is asking you to input the range of y. It is just like before. Now it is asking you to give the results of the input, the independent variables. Now earlier it was only speed, now we have another one, that is tire age. You want the result, say I want the result to be given over here. Now let us have a look at the results now. your your regression equation is y is equal to alpha plus beta 1 x plus beta 2 x1 beta 2 x2. That is, this y is nothing but your accident is equal to the intercept term plus beta 1 of speed plus beta 2 of the tire age. Now, what is the value of alpha? It is coming over here. This is the value of alpha, 41. What is the value of speed? Now, the value of speed is minus 0.71. We will come back to it. What is the value of beta 2? The value of beta 2 is tire age. What is the R square? 0.91. Now, we stop here, but first understand few of the things. Intercept is fine. We have got an intercept as 41. Now somebody might say, "Oh, how come when the speed is zero there can be an accident?" Although it can be a case I am waiting at a crossing my at a signal, at a traffic signal, and somebody comes and hits me from back. Nevertheless, but I'm not arguing for that. But the values. The next thing is speed. What does this indicate? Minus 0.71. This indicates that if I increase the speed by 1 unit, the number of accidents would come low by 0.71 units. Theoretically, conceptually, this is completely wrong. You cannot justify this by any theory. The third one is tire age. It says that if I increase the age of tires, the number of, when the tire age increases by 1 unit, number of accidents will increase by 0.69 units. But so intercept, okay, we can accept the result. Tire age also we can accept the result. But what has happened with the speed? Speed has given a completely illogical result. This is a problem. If you remember the classical assumptions of classical linear regression model, one of the assumptions is that the independent variables are not related. We have not emphasized this assumption in the simple linear regression, because in linear regression there are only one independent variable. There are no two independent variables. But here, when there are more than one independent variable, there can be an additional problem of multicollinearity. This problem, that is, your sign has got reversed. In reality, it should be x1, but we have a sign which is in reality the sign should have been positive, but here we are having a negative sign. This is what you refer to as the problem. This because most probably due to the problem of multicollinearity. Multicollinearity happens when the two independent variables are linearly related. Okay, we will take that to the topic of multicollinearity once we have completed everything about multiple regression. But at the moment, this is how you get the results. Now, again, R square. Now we come back to R square. The basic thing is, here R square, when we have taken only one variable, speed was 0.62. 62% of the relationship of the changes or the variation in accident was explained by speed. But when we increase one more variable, that is the age of tires, now 91% of the variation in accident is explained by speed and tire. Again, another word of caution over here. Since we are taking two variables, we have to adjust for the degrees of freedom. So in the case of multiple regression, we do not estimate R square. Rather, we concentrate our results on adjusted R square. So we can say that, if you want to say the relationship between accident and the two independent variables, we can say that these two independent 88% or 88.57%. So approximately 88%. Here it is 0.885. So we multiply this by 100. So we get it in the form of percentage. It says that 88% of the variation in the dependent variable accident is explained by its relationship with speed and tire. So, what are the takeaways from up till the discussion till now is, we have seen that we can use regression when we are having more than one independent variable, it is referred to as multiple. And since we are dealing with only linear regression, this is multiple linear regression. Next, we have seen by using Excel from where we can get the values of alpha, beta, and in multiple regression, beta 1 and beta 2. We have seen that how to where the value of r square is there, and more or less we are in multiple linear regression, like that will what we will be discussing now and forth. So that is we do not go by the value of r square, rather we do interpret the relationship by using adjusted r square. Other things which we have seen, how to the probabilities by the help of p-value, how to say a variable is significant or not. Now there are certain other things also, like here these are the same error squares and mean error squares, all these things are here. But at the moment we concentrate ourselves to the case of intercept, beta 1, beta 2, r square and adjusted r square, which we will be looking in our coming classes. Thank you.